And so let us continue to our discussion. So we ended the last time speaking about the local protocol of transport Ethernet. And so Ethernet is how to pack data to be sent to computers that are, say, directly connected to a bus, essentially. When you want to send the data to a computer or a server which is outside your local area network, you have to use other protocols. One protocol is the TCP IP protocol, which is essentially transported inside the Ethernet packet for the local communication. So the idea is that every computer that is directly accessible, at the beginning, all computers were directly accessible, has a number, the TCP number. And so you have to send data to, for instance, from the client. Let's suppose that you are connecting to a web server. So you send a first packet in order to say, okay, this is, I want to establish a connection. The server responds sending an acknowledge, and then the another signal say, okay, I'm accepting your connection, and then data can be transferred one in one sense and also the other sense. It is a bidirectional channel, and each packet of data may contain acknowledge, if everything has went well, of the previous transmission, plus other data, or just the acknowledge. And clearly, if you don't receive the acknowledge, you have to resend the data. And so you see here the link level is the Ethernet level. Then you have this packet for TCP, and then you have the data according to which kind of application. Then in a moment we shall see the UDP transport. So TCP is an accurate way of transferring data, but the problem is that it requires an acknowledge for every packet of data. So it generates a lot of traffic. And this is not good, for instance, for streaming or other kind of massive transfer. So another protocol was developed, the UDP. UDP is a protocol in which you send the data without waiting for the acknowledge of the other data. And they can be received in a order which is different from how they are sent. So, for instance, because they have taken different routes. And in this case, it is the task of the receiver is that of putting all packet in the right order, and maybe ask again for those which are missing. Clearly, for streaming, you don't ask for missing packet because time has already passed, so you can see disturbance in the screen and the video, for instance, but that's all. But in case you want, for instance, to record, you can eventually ask for the previous the missing packets. And clearly the idea of now of the modern structure is to differentiate clearly between among the different levels, things that is not always say this protocol is not always followed historically. There are a lot of processes on network, like for instance telnet, which mixes all the levels together. And okay, so you don't need for the TCP IP protocol to know where all other systems are, and because you have routers which have some map of the internet, and who can route the packet in the right way. This can also depend on how where the packet come from, because you can ask for a quality of service greater, paying more than others. And so the router table are one of the arguments of computer science, which is still studied and investigated. And okay, so clearly you can have routing protocols that not only addresses the right packet, but can also act as say a front end, say for instance masking a whole subnet behind a single TCP number, like things. These are things that happens, for instance, in your home. You may have, I don't know, tens of devices inside your home, with each one with its own IP number, but when you exit from, for instance, a DSL router, all packet appears as coming from the same router. The fact is that each time you establish a connection, you also assign a number, which is called a port, to this connection. So when you mask your internal packet with the IP number of the router, you are also keeping track of the channel, mapping it on some port, which is then used to know which internal computer is to be answered when the response comes from the other backend. And so routing table are one, as I say, one of the present information research field. And finally, you don't want neither to know the numbers, also because nowadays this can change or can be just virtual names, virtual numbers. So there is another protocol which is widely used, which is called a domain name system, and which essentially does the translation from one symbolic name, a string, to the actual IP number. And clearly, DNS service is a crucial service which can be the target of cyber attack, for instance, saturating the DNS server so that it cannot answer, cannot resolve the request. And also it is another target of attack, because if you are able to access the request done to a DNS server, you essentially know which are the sites or which are the services used by all users. So there are a lot of information disclosed, for instance, to service providers, just because one is using its DNS number. Even though you use a protocol, a secure protocol like HTTPS, the request to the DNS server occurs in clear. So your provider can see what are you transferring, but from which site you are transferring. This is an available data. And okay, so one of the first application was email. This was simply ported from the UUCP times. You remember the Unix to Unix copy. And the format is not so difficult. Again, you have symbolic names like the usual email addresses, and also essentially routing tables where to send this message to. And so it is very old. You can see that it is at the beginning, so mid 60s, and the format has not changed a lot, except that now the way of embedding non-textual material is in some sense embedded, included into the client, so you don't see, you attach, for instance, a file, or you attach an image without problems. It is the task of the browser or of the client to convert, for instance, a binary data to characters, printable characters, and for instance, using base 64 coding, and then decoding in a transparent way the material. Now let's come back to the user point of view. We are still, you see, in the end of the 60s, and it is quite astonishing to see. Let me see if I can share this video. I don't see. Maybe okay. I have to switch to some. Okay, maybe here. Okay. So this is a demo of a system presented in the 68 by this Doug Eberhardt, and so he shows a system he was developing using a particular keyboard, the mouse, and another keyboard here that acted like a piano. You could press more than one button at a time. And so it shows that you can use the mouse to select characters, and then to have applications like kind of file systems, and then it shows also hypertext, so it can click and open pieces of text. And finally, he shows that he can, in his system, he had also the possibility, say, of connecting. Let me see where it is, the part in which they show a video connection. Here it is. He can connect to another user at distance and have a video, audio talk with him. Clearly, he has not developed a Windows system. So everything was, say, appearing in some position of your screen. So the the demos was astonishing, but the problem is that the system was extremely difficult to be used. So this is the first lesson that we can say extract. You can have a lot of good idea, but in order to be successful, things has to be also usable, not only say smart. So another, let us now pass to the field of communication. So how to use communication beyond, for instance, email. So one of the first system to be used from home, where clearly network and was not like today. So you didn't have the connection to the TCP/IP to internet directly. So the way of communicating was through the BBS, the bulletin board system, which were contacted essentially using modems and telephone lines, and that used to offer some so more or less sophisticated interface, generally textual interface, but sometimes also with some approximation of a visual interface. And you could essentially, first of all, download the files, so maybe possibly games, then exchange messages with other users, and after some time also sending email using internet. In the meanwhile, there was a lot of interest, say you see, we are still in the 60s, a lot of interest in using computer for education. For instance, already in this project Plato, there was the idea of having graphical interfaces to say to offer kind of hypertext essentially, and to use a touch screen. Here there is an ancient touch screen, terminals explicitly designed to be used by students, and also all kind of things that nowadays are say advertised as the modern concept of teaching. So essentially forum, message boards, online test, email, chat rooms, etc. All this was started in the 60s and up to now not very common. Okay, so the birth of internet occurred not with the protocol. The protocol was already used, but in general it was used to connect a couple or very few universities or research centers or defense centers. But at a certain point, this is the map, for instance, of the whole internet in the, I don't remember, in the 70 something. And at a certain point, establishing connections and connections, all United States and then essentially all the world suddenly was interacting through a common, say, a network which was always active, because clearly you could always connect using telephone lines, but it was a sporadic connection. In this way, you could set up services which can be reliable, be accessible at every moment. Clearly, this started with as a project of defense. So, and this is why the internet protocol, essentially TCP/IP, is such a slow but robust way of communicating, because it was planned to be usable even after an atomic attack. At a certain point, clearly, the military this has not been translated. The military section abandoned essentially ARPANET, which then became internet and was and isolated itself. But at that time, it was not the only network existing. For instance, BitNet was completely separated the ways of connecting essentially IBM systems, and it has its own protocols. I remember I used the BitNet for sometimes because some researchers was on Bitnet and not on internet at that time when I entered the university. And Bitnet so had its own, for instance, a way of specifying email addresses and servers and systems, because, for instance, the main difference was that the IBM systems are so with a business model in mind. So they were essentially designed to have a form where I have fields that can be filled, and then the whole form is sent, and another form was downloaded. While in mostly or most of the time, service in the TCP or Unix world are terminal ones. Say using a prompt, you type the commands or use an editor, but so as a whole terminal, not just field. So there was ways of emulating one for the others and so on. Okay, clearly they had when the network was present, they started also to develop systems. Most of the systems used by general common people was serviced by modems, and so for instance, databases of laws, news, and so on. And so this is the one of the main channels by which computers entered the home or families' houses. The idea is to say offer essentially news, booking of say hotels, flights, and so on. And so you can see here an advertise of the 69, in which they say, okay, we had a party yesterday with a lot of people, and I only had to wash one glass because essentially in the 69 it was mentioned to have the opportunity of having essentially say an online chat system. And this vision, however, in the USA did not get much attention. Clearly, CompuServe was connecting a lot of users, but still not very popular. While in France, it took really place, and so in the 80s, clearly much later, but almost every family in France had a Minitel terminal, which was a text terminal essentially, by which you could do everything you do now, you using essentially the web. And clearly also the lower protocols were not essentially unique. Other protocols, like for instance X25, which was developed especially for using telephone lines, or Teamnet. So there have been a lot of different say solutions that only at the end were so fused or maybe absorbed by internet. And also clearly law had to played a fundamental role, because for instance it was illegal to share traffic on the same telephone line from different sources. This was explicitly forbidden. So, but if you had a device before that essentially multiplex several connections into one line, one channel, and another one at the other end, which demultiplex this traffic, this was allowed. So essentially how software and hardware started to be sold. And clearly, I said that at the end, all networks converge into one. This is because clearly networks are useful. The more people are more useful, the more people are using it. So if everybody or but few use internet instead of, I don't know, bitnet, clearly bitnet is quickly being abandoned because it was of less use, essentially. And so essentially what happened in the 80s was that every services, even those like FidoNet, CompuServe, and so on, which had their own network, opened gateways in order not to be cancelled by internet. And so essentially this is also why internet at the end it was used. Even though you can see still in the 80s, the National Science Foundation policy, which funded essentially the build of internet, still permitted to use internet for private or commercial purposes. So you can see here the growth of internet, which is essentially so exponential after the beginning of the 90s. And clearly, the connections were much faster than using telephone lines, but still slow enough that you could not transmit essentially music or videos and so on unless you find a way of compressing it and using less bytes. So this is the 70s is also the period in which a lot of protocols for data compression have been developed. One of the most famous was Lampel and Ziv, I don't remember if it is exact, compression scheme. Clearly, compression scheme can be lossless, in which you try to exploit the fact that your message has not the largest entropy, so is not composed by random bits, and so you can, for instance, shrink sequences of ones or of zero, or for instance use a dictionary in which you start saying, okay, the first item is a single bit 1 and 0, then when I meet a couple 0 1, you say, okay, this is a block made by block 1 and then block 2, and then you start to assemble a tree of all blocks that you find in your data, hoping that not all blocks are appearing. And so clearly in this way you can also see, okay, there is a block repeated several times, and so on. And so these are essentially the approaches. While for lossy compression, one is essentially exploiting the transformation of the data into the frequency domain. This is a thing. There is a very nice video in Veritasium which explains how the fast Fourier transform was fundamental in order to develop a lot of things. So the idea is that if you transform something which in the frequency domain, this means representing some periodic, in principle, data using superposition of sinus and cosinus. This, in principle, requires essentially a change of basis, so it requires the multiplication by a full matrix, but this is extremely slow, while exploiting the characteristic of data, you can essentially, instead of having something that grows like n squared, you can do this having something that grows like n log n. And so this becomes practice and useful. This techniques was developed in order to analyze signals that revealed the explosions of Russian atomic bombs from the atmosphere. And the idea is that to try to separate the audio and video data into a portion which is fundamental and which say cannot be deleted without losing everything, and the part that can be essentially thrown away without affecting too much the performances. So, for instance, one can, like in the old telephone system, you can just cut the high frequencies because the human ear is not very sensible to higher frequencies, or you can try to decompose your image into a basis of, for instance, this is a Fourier basis, I shall illustrate it in a moment, in a local Fourier basis, so frame by frame and eventually portion by portion of your frame, and then throw away those components which are not, which are essentially near zero. So, for instance, this is a b-dimensional Fourier basis. You can see the lowest frequency is constant. Then you have half wavelength in the X position, half a wavelength in the Y position, and both combined, then a full wavelength, 1.5, and so on. And so these are essentially the components of a Fourier transform of an image. And so you perform some algebra, essentially the matrix multiplication, and then you can compute the weight of all these components, and then you can filter, say, maybe throwing away those which are not important. So this is for image compression. This is how JPEG works. And for video compression, you can still compress each image of your video, but this is essentially not saving enough. This is the first video essentially used this system was, I think, MPEG level 1, something like this. The idea with level 2 is to exploit the fact that in general two subsequent images are not so different, so you can just store the differences between these two. But this is not working well, for instance, if you have something that shifts on the background of your image, for instance, when you change the point of view. And in this case, this was MPEG, I think, level 4. You try to find also transformations, linear transformations of your image in order to, for instance, save the translation of a background and adding just the pieces missing. And so you have now a chain for encoding your video. And the idea is that you can, for instance, prediction is quite slow because you have to try all possible displacement of your image. But the idea is that you can have also in a hard, so computational intensive phase of encoding if this allows a quick and easy decoding, so that you don't have to use very sophisticated hardware and software for having, say, a video player or something like this. The Data compression is also used for cryptography. The Internet Protocol have been developed without any cryptography in mind. So you have to put cryptography or data security at the application level. So inside the packet being transported by internet. So clearly, the first step is to use Caesar code. I mean, shift the alphabet by some amount so that each letter becomes another one. This this way of coding can be easily broken simply by looking at the frequencies of symbols. For instance, the E is much more common than the B, so that you can discriminate this shift simply by looking at the abundance of your patterns, or the symbols of your patterns. But a real coding cryptography system changes the code, so the shift between the alphabets for each, character encoded. So the real key now is how these shifts are changing along the messages. And for instance, Enigma, the German cryptographic machine, was based on a similar approach. In this case, the key was the arrangement of gears that made the transformation of the mapping change every character it was typed. And but this the problem. Okay, so cryptography can be quite secure. The problem is how to exchange the key in order to be able to understand the code and decode messages. And this was the main problem until the discovery of the public key cryptography. So the idea, and we shall maybe see in a moment, yes, how it works schematically, but the idea is that you may have a protocol which is quite hard to be broken, that allows to separate the keys into a private keys, which is kept secret, and the public key, which is say given to all the world. So you can have a ways of encrypting a message using the public key, so that only the owner of the private key can be decode it, or vice versa. You can encode something using your own key, and the others can decode and so verify that this message is coming for you, because it can only be decrypted by the associated public key. And so essentially you need some hard problem to be solved in order to do this without having the keys. And one of the most known ways of having a public and private key is to use the fact that it is quite difficult to break a large number into a product of two prime numbers. And so there is a protocol which I have not studied. It implies the small, don't remember, the Chinese problem and the little Fermat problem, others that I don't remember. So there are essentially ways of coding a system using two large prime numbers. And so the idea now is to be able to produce very, very large, say 256 or more digits, prime numbers. Okay, so this is essentially the background. Now we shall came back to the market, because from now on the market will be the dominant force in the evolution of at least a field of computer science. So the first mass products using electronics was essentially calculators. This is Wang electronic calculators. We shall meet Wang again, or Wang, in a moment in the field of electronic publishing. And so you can see that it was not so, say, cheap to have a home calculator that could, I don't know, do few operations and not so much more. So, for instance, a home calculator costed about $5,000. So, but the big revolution was the CMOS technology instead of the bipolar transistors. With the CMOS, you could, as we have seen in the last lesson, you can embed all the circuit into one integrated circuit, maybe with a few discrete device, one discrete component or leftover. And so you see the sudden the 68 5,000 in the 70 to $150, and the prices started to fall down, and also a lot of new devices started to appear, like a calculator that could fit into a pocket, digital clocks that you may also, if I remember well, in that time, one of my friends, or maybe a bit later, had one of these first models of digital clocks, and he was able to read no more than, say, 20 times or maybe 10 times a day the time, because otherwise the battery did not last more than 1 week or something like this. But you see that, for instance, in the shuttle, they use a lot of hand calculators from HP, even though the shuttle had, if I remember well, 5 IBM mainframe inside, but it was extremely more convenient to use this kind of marvel than using the central mainframe. And in that time, the Moore from Fairchild, one of the first enterprises who produced the integrated circuits, started noticing that the number of components of the single chip was doubling every year. And so this is the first Moore graph, say, extrapolating this growth for at least some 10 years. Actually, the Moore law continued essentially up to now, doubling the power or the more than the number of components every, a couple of years. So the Fairchild was quite a traditional enterprise. So, for instance, Noyce and Hill left Fairchild for, say, essentially they carried away a technique developed by Federico Faggin. At least this is what Federico said 3 days ago in the engineering faculty, so in the engineering school where he was invited, that he developed a technology which allowed to make CMOS devices using only silicons without a part made by aluminum. And so in this way, one could shrink a lot of the size of the system. And so Noyce and others left Fairchild for making Intel essentially thinking of selling memories, which were at that time the most expensive things of a computer. And so you see that the idea is that you can have slower devices, but much lower than TTL, but you could shrink, say, some hundred of bits or thousands of bits inside a single chip, while the alternative was to use ferrite memory, which were extremely more expensive and slower than this. Federico Faggin, after a while, also left Fairchild and then passed to Intel, and he started designing the first essentially CPU on a chip, a microcontroller all on the chip. This is the 4004, which is the beginning step. It was a 4-bit computer. After the 88 and then the 8080 chips that made essentially Intel famous. Finally, he also abandoned Intel because Intel was losing time, still betting on memories instead of microprocessors. And so he founded the Zilog and produced the Z80, which is one of the most famous and powerful also chip of the time. And Zilog, he was telling 2 days ago that he started in 11 persons, and after some, say, few years, he had about 10,000 employees in this enterprise. So essentially, it was a big revolution, and one was one of the reasons for this. Clearly, the performances of the chip were important, but also the fact that the Z80 was an open project which could be adopted and copied by a lot of other enterprises, clearly paying royalties. But for instance, a lot of producers in Soviet Union did not pay anything and made clones of the Z80. Clearly, this meant that a lot of hardware was developed for this microprocessor, and so it was also adopted more and more. And so in the Intel, they started instead producing and developing the lines of this 8080 processor, which was both were essentially 8-bit processors, but one with the 88 was with, say, a small number of pins, so it means that it could only address a limited amount of memory. And so in order to address more memory, as I said the last time, the idea of segmented memory was developed, so that since it has only 8 pins, 8 bits to address memories, the idea is that you put first a number on the address bus saying, okay, which page of memory I am thinking to use. Each page was 256 bytes or words, I don't know. And then using for the second, so without giving the signal for changing pages, you could address all data within this page, and then you have to change page if you want to go to another address. While the 8080 had more pins, and so he had the possibility of directly addressing 16-bit memories, I mean 32,000 locations. And again, you could also have a paging system for this larger address space. So you could have 32K pages addressed with just one shot or one clock in the address bus. Otherwise, you could change the memory, the page of the memory. And the family of the 8080 is a CISC processor. As I said in the last lesson, if I remember well, CISC means a complex instruction set computer, and this means that you can have a rich language, assembly language, with which you can do many different operations with just one instruction. But the problem is that each instruction can have a variable number of arguments. So maybe one instruction only consumed one word, others 2 words, 3 words, more words, and so on. And this is extremely nice for human programmers. I remember having worked on the assembler of some processor in this family, and it was almost like a high-level language. But the problem is that compilers have very large difficulties in trying to optimize the code, because it was difficult to change the order, for instance, of the operation, to replace one operation with others, and so on, or to get together. And how all these devices entered the home market, essentially, as we shall see many times in the following, because of games. So games which were quite different from those we are used to today. Many of the first games were essentially analogic games. For instance, this is a console with which you could play Pong on the television, but it used the cards. But the cards were essentially ways of wiring in different ways things together. So essentially, it was not active. Just wait a minute. It was not an active component with memories. It was just a wiring of pins in different ways. Just let me send a message. And so, since it was black and white, it had also a lot of different, say, gadgets. For instance, transparent films to be applied to the television, so to have colors, and also other, say, other things that we are not used to think associated to electronic consoles, like so cards, logic boards, and so on, dice, poker chips, etc., etc. And while this is also, you see, we are now passing in the 60s, we are now entering the period of consoles. Consoles means something that will stand by itself in some public place, like a pub or a bar. You use the coins to to buy a game, and then with joystick you played. And all of this used some screen, essentially a television screen, and the games were essentially quite primitive, like a kind of a Pong game or the tennis game, kind of this. And you see, the investment in making the console was quite large, because you had to build up everything, say, by wood. Actually, you could also use plastic. And one of the memory from the pioneers of arcades in Atari was that at the beginning they built the first prototype. They were not sure that there could be a market for this, and so they installed it into a bar with a milk carton as here as a money bin, and then they noticed that almost instantly a queue of people formed that wanted to play, and the machine so stopped to work when the milk carton used to collect money was full. Uh, and so this was the beginning of arcade games that started to have very different shapes. Again, also, for instance, this is the famous Breakout game. Again, it was a black and white game using plastic colored strips in order to appear as if it were in color. And the interesting point is that at the beginning, these games were not using a microprocessor or even programming. They were assembled using electronics. So you had to design a circuit in order to, say, move your cursor on the screen, keep track of the position of the ball, and so on. And this is, for instance, how the founders of Apple, Wozniak and Steve Jobs, entered this history. So essentially, they were a kind of, say, hacker. For instance, Wozniak, who is a genius of the electronic. One of the first devices he built was this box that using say an audio device in order to reproduce the sound of the coins falling down into the telephone circuit, in the telephone box, was able to let people telephone without paying, essentially. So they were selling these hacker devices, the blue box. And so essentially, Steve Jobs was a kind of drug dealer, not selling drug, but selling this kind of devices. In the 73s, Jobs was hired by Atari, and they wanted to build up a home device for doing the Breakout game, but not using all the circuit that were used in the console. And so clearly, Atari offered $100 to Steve Jobs for each chip saved. So Jobs passed this work to Wozniak, which was able to save 50 chips. But Jobs told Wozniak that Atari only paid $700 instead of 5,000, and so they shared this. So this already revealed how Jobs was able to carry cash on its own pocket. And so clearly, at the end of the 60s, finally the games based on microprocessor and so program that started to appear, and this also implied that games were more, say, rich in more interactions. So, for instance, instead of having the classic Space Invaders again in black and white, you could have the console of Space Invaders. You could have a Galaga with colors, with things that floated around. Even though the idea is still the same, but the interface was extremely more, say, sophisticated. Clearly, not like today, but. And for instance, one of the fields was using, you remember that the terminals at the time were essentially of two types, one based on characters and pixels, and one based on vector graphics. Also, games were divided mostly using, say, bit mapped screens, but also I remember having met some of them. Games using vector drawing, which had extremely more sophisticated look at the time because the resolution was extremely high. And one of these was Asteroids, in which you draw, you can say, turn your spaceship, which was just a triangle, fire, say, projectiles with a limited number, because only a limited number of objects could be, say, active in the screen, and you have to avoid the asteroids and aliens. Okay, as usual. Another famous one that, if you have never seen, have tried to find the evolution, the web implementation was Qbert, and this was extremely interesting because it lived on a world with different directions of gravity. So he used to jump down this, or jump high and down on this, say, kind of steer. But there were other things, so monsters that attacked you that may had a different gravity orientation, and it was an interesting game. Clearly, going on with the years, a more sophisticated game appeared, like the famous Pac-Man, which was originally called Pac-Man, written in this way, which to pack is something like to eat, or close and open the mouth, but they feared that it was, say, pranked like a fuck man, so they tried to change. So what you know is now how the Pac-Man name origined, and was still an arcade game at the time. Okay, so finally, home computers start to appear, and one of the first was the most famous was the Altair 8080, 8080, and this was an extremely Spartan computer that 8-bit computer, clearly, based on the 8080 processor with 256 bytes of RAM, you see, without any paging. And it had a switch-based interface with the switches that sometimes did not work. So to program this, you had to insert with the 8 switches the memory address, with other 8 switches what you wanted to store, and then press a button somewhere. I don't remember, I never used it, somewhere to store the byte in the location of the RAM. Then change the address of the RAM, input another binary number, store. And so when you finish the loading the program in memory, there was a button run that started from a given address in memory and executed, and there was no output. The output was again a series of LEDs that flashed. So you have to read the answer as a binary number by the LEDs turned on. So really, this was important, first of all, because it was based on a bus. Essentially, it had nothing inside. The whole case was empty, but you could buy cards to be fitted in this 100 connector bus. And so in this way, you could say attach a keyboard, attach a terminal, attach a printer, or some disk reader, and so on. It had just with nothing, so nor the ROM in BASIC. So you had to buy, say, one card with the BASIC installed. But it was extremely popular, so that it was sold in a lot of copies, and clearly Allen and Gates that already had developed. So you remember, we have left Bill Gates working on the PDP computers. On the PDP computers, he had an emulator of the 8080, and so he was able to develop the BASIC for this Altair, and this is the I think the photo of the original BASIC tape, which was stolen and copied by a lot of people, and which caused the Gates, when attending to a convention, to make the famous speech in which he said, okay, making software cost times, so you had to pay for software. It is not free things like everybody at that time considered to be. And so you see how things worked. So you can see, now I come back to the other, but you can see a version more sophisticated, but essentially the same, a clone of this console in the movie War Games. I don't know if it was really connected to what was shown in the movie, but essentially the player in this movie used fictionally this clone of the Altair connected with the modem to scan all numbers of BBS or telephone numbers, looking for a BBS from which games could be downloaded. Actually, it was contacting a military computer, which thought to be contacted by his say programmer, his father, and wanted to play a thermonuclear war, which was a real thing. So then computer started to try to launch the atomic bomb by itself, and it is a very nice movie with a lot of quite realistic details. Clearly you didn't use the Altair or any kind of computer moving switches. You need an operating system, and one of the first operating system for this kind of computers was CP/M, which is essentially very, very similar to the DOS. I think that DOS is essentially a simplification and a copy of the CP/M interface. I used once CPM when I worked in a software house to recover data in a very old computer, and it was really similar to the DOS. So you see commands are slightly different. The CC instead of a copy, but it was very similar. Actually, the CPM was much more powerful than Microsoft DOS or IBM DOS, and because it was multi-user and multitasking, but clearly it was adopted by also by large so installation, large computers, but it was never so successful. And the thing that was the very innovative invention of CPM was the BIOS. The BIOS means that you then was ported in ROM, but essentially the idea is that you abstract the call to the basic hardware, maybe how to write a character on the screen, how to read something from the keyboard, how to read something from a disk. This clearly each vendor of keyboards, each vendors of screen, of disk, had its own protocol in order to move, I don't know, the head of the of the the reading head of the disk in a certain position and so on. So instead of writing down different software for each different hardware, if you have a translation layer, a compatible layer that translated the access to the hardware into an abstract call to a function, you could port, you could first of all install a lot of different hardware without having to recompile the programs. And then you can also port your operating system to different, say, structures, different hardware. And another interesting point concerning this movie is that at a certain point you have this fictional computer war room into which you can see a lot of different monitors and a lot of screens that in color represent the countries and then the trajectories of missiles and so on. But actually all of them were in black and white, and they used a kind of say multiplex technique in order to draw the patterns that had to be shown in the movie in different colors, one after the other. This was synchronized with the color filter that rotated in front of the camera, so that essentially the movie could be shot in color, even though the screen were in black and white. And it seems that I don't remember which president, maybe Reagan. I think Reagan, yes. When he was elected to the president as the president of the United States, asked to see the war room that he has seen in the War Games movie. He was also concerned that he also asked that if it was true that there were backdoors able to enter the computers of the security, so without passing through all the levels. And actually, the study shown that almost all devices had the back door left open by developers because not for say evil goals, but just because being able to maintain the system without always have to explain and ask permissions and so on. Okay, so the end of the 70s is also the time in which the first personal computer started to appear. You can see here the Tandy, the Commodore PET, and the Apple II, because the Apple I was essentially sold as a for people that wanted to build up their computer in by themselves. And then clearly the Commodore and the Apple were quite expensive and targeted to a high level audience, while for instance the Tandy was sold as a real home device. You see that most of these devices were used the Zilog chip, and also that one of the things that was considered essential was the BASIC, because BASIC was used essentially for doing anything, almost replacing the operating systems. Clearly, you can see also how the Commodore PET was aimed at the business world, while the Apple II was sold, for instance, using with two joysticks, because it was considered that one of the main say way of using a home computer was to play. While this was actually not true, because clearly Apple II was designed by Wozniak. He says that he designed the Apple II because he wanted to have the breakout game in software. So essentially, he had the audio chip, he had the joystick controller, and some graphic of the screen, color graphic of the screen, because he wanted to play, at least this is what Wozniak says, breakout on it. But actually, the killer application was a VisiCalc, essentially a spreadsheet. And this was really the drive of the Apple II selling volume, because essentially said that the people wanted to enter the computer shop to buy VisiCalc and exited with an Apple II, because clearly it was the only hardware able to run this application. And clearly there was also, this started to say somehow divide the target into home computer or personal computers. The idea is that the personal computer was essentially for businessmen who wanted to have a personal computer, while home computer targeted the whole family, so that, for instance, he had to offer games and to offer entertainment and so on. You see, that essentially, for instance, while the Apple II was adopted by a lot of schools, this means that a lot of people exited the school having in mind that the computer was the Apple II. This was a strategic a choice. While, for instance, the Atari 800, which was essentially with similar capabilities, but was targeted for a home computer, and so it had to have a lot of games, a lot of entertainment, but it was also considered something which different from the education or business application. And so you see, for instance, how there was also an effort, in particular in the United Kingdom, an effort for educating young people to the computer era. And so they had a lot of, game and books trying to carry or to interest young people into the computer world, clearly in a very naive way. And a lot of, devices appeared, essentially the brother of the big one, but reduced in order to stay into a budget, a home budget. So, for instance, the famous Commodore 64, the Sinclair VIC 20, sorry, Texas Instrument, Sinclair Spectrum, and so on. And so you can see here an advertisement showing that with the same computer you could play games, and then so having a family budget, and then I don't know, listen music, and so, and education and study and so on. So nothing new with respect to today. And the Sinclair, the first ZX81 and then the Spectrum, was one of the most somehow advanced things, because you can see here that it had only 4 chips, where everything was so shrank together, and it costed very little. Unfortunately, it had a very terrible keyboard, essentially not usable at all, and but it was really a revolution. And in some countries, it was essentially produced in a massive way. While on the other hand, in the UK world, there was a more, say, prestigious competitor, which was this BBC Micro, which was offered to schools, a bit more sophisticated, and that could download programs from television, essentially, because the teletext pages, I have seen something like this during the night, also here in Italy. You could you saw just the pages full of strange symbols, but if you were able to download the page into a computer, it was essentially a program, so it could be transferred to RAM. I don't know how, and run. And okay, so now you can imagine that there is that starts a strong competition between consoles, which had a better graphic and better feeling, but was dedicated only to games, and home computers that could also run games. And you can see, for instance, here, let me show you a classic advertisement of the Commodore VIC 20. I had to change this somewhere here. This is an advertisement of that time, in which you see this job employer. They say, okay, you in your job application, you say that you have killed the 20 million invaders from the Mongo planet. And they say, this is computer games, but what do you know about real, in some sense, computers? So essentially, while consoles were more, say, good for playing games, the idea of a home computer that it could be used also for other things. So you see, the after the VIC 20, essentially was we have seen before was the VIC 20, but the Commodore 64 was essentially the same. With essentially the same case, but with say better graphics, and so not very different. I've never used both. I've seen, I had one of these computer in the department when I entered, but it was, say, abandoned because it was already too old. And the problem is that if the competition is for the home market, you had to keep prices low, and this means lowering the quality. While the Apple II was aimed at the high market, so it had a very high standard, it was reliable and so on. You see that more than 30% of machine delivered had to be returned because of something that did not work. And clearly, at the end, this makes the difference. Another point, interesting point, is that this is the time in which gender start to differentiate in using and choosing a computer job, because in the 40s and the 50s, most programmers had so first experience at work, then in school, and essentially they were all the same choice for women to law or medical or physical science or computer science. You see here, in the middle of the 80s, they start to differentiate, and with women essentially not choosing anymore the computer world to study computer science, and essentially because with home computers, the figure of the classical, say, computer passionate, who dirty, not not so living for computers and so on, started to, so the classical geek, started to be considered as the classical way of being a computer passionate, and this implies being a male. So essentially, at least this is the interpretation. So with the diffusion of home computers and also online services started to appear. So you could say connect to some service like a CompuServe, Prodigy, and first of all download. This is a recent interface, but download, say, games or pay for games, having news about sports, weather, and so on. You can see here, and exchange messages with others as a forum or sending messages. And with the power of, so you have seen that the other aspect of gaming was having a console. So the console is something that specialized for gaming, so with the better graphics with respect to computers at the time, at least, and maybe interfaces like joystick and so on. And one of the name in this field is Nintendo, other is Sega, and the other different aspect is that computers normally use the floppy disk, and floppy disk games could be copied, while console use the cartridge, which could not be easily copied. So this was clearly, from the point of view of who sells games, they prefer to sell consoles so that they can also sell games. But from the point of view of users, they prefer to buy a computer because they can have a lot of free games. And you see that this coincide with the disappearance, essentially, of arcade games. In the War Game movie, you can see that the main player is also a passionate user of arcade games in a game shop, essentially. And the point, the business world started to be penetrated by computers, essentially by means of office automation. I mean, essentially because first of all, the writing machine become electric. Then with the capacities of, say, storing the text also on disk, or maybe first displaying a line of text before being printed so that one could check if everything was okay. And so this is for instance, how Olivetti pursued this transition. But the big revolution was the Wang word processing system. So Wang, which we have already met, selling essentially calculators, thought that one could sold a whole computer system made of terminals, so computers, printers, and storage, say disks, that were dedicated only to text processing. So he developed the idea of a terminal or an intelligent terminal, since essentially a small computer with another one who took care of the storage of text. And this was extremely successful because at that time you see that Wang Labs was considered at the same level as IBM or DEC companies. And again, this lasted for some times because in the meanwhile, computers, programs for dealing with text, before text and then also spreadsheet, started to appear for home computers, for instance, the Commodore 64 or like this. And clearly, they had to find a way of everything was new at that time. So essentially, how could you insert the text and the commands to format the text and the commands to, say, move inside the page using just a keyboard. So for instance, you can see here that one solution was to have a certain control text. So control text means, you remember the ASCII system, you had this first part, Control A, Control B, Control C, and so on, which were essentially character using for communicating with printers or with modems. Another use of the same characters was to encode, for instance, a movement of cursor, because you had not the arrows in the keyboard, and also for formatting text. So you have to develop a lot of different, say, protocols. While, for instance, in the Unix world, the VI system, which was designed to be used with any kind of keyboard, only used the printable characters. And in this case, you had two modes, the insert mode and the command mode. So there were a lot of different solutions. And the first users, professional users of this system were journalists or people paid very little for a lot of text. So they had to develop a way of quickly producing a lot of text. And for instance, saving the time for copying the text, since other writers use the classical electric machines, but in that way, text had to be scanned, transmitted, and copied by someone else to enter the production, while in this way he could simply send the text by modem or something like this. And this is also the improvement in the miniaturization of electronics made it possible to start to think to portable computers, not laptops, they had to be connected to the electricity, to the plug in order to work. But they were so transportable, because I think that something like this weighed about 15 kilos and so on. So you can see this was one of the first one with floppy disks and this very small screen here. While, for instance, the Amstrad with the printer, I remember that it was. I think I have seen one example of this. It was really a big revolution, because it followed the strategy of Sinclair of having a small number of highly integrated custom chips, so that it could save a lot of money of wiring, essentially, inside the computer. And but again, the main say engine that increased the selling of hardware were essentially killer applications. Killer application, we have already seen VisiCalc for the Apple II, and this was the beginning, because essentially when the application started to be ported or copied with in other hardware, this also coincided with the decline of the earlier seller. So the 80s dominated in the upper part of the market by the Apple II. Was also time in which the IBM PC appeared. So the IBM started to consider the idea of entering this home computer market, but since it had already experience of say having partners, so they did not want to develop this by itself. They wanted to say have someone else to develop this, which was extremely experimental and was not considered to be a source of large revenues. And they did not want to have a full partnership in the development, because if I have read well, they had bad experience with partners that then asked for, say, more involvement in the management and so on. So they developed the hardware, but the whole software was, say, decided to be assigned to an external contractor. And clearly the design is extremely more, say, traditional with respect to that of the Apple II, which had the integrated keyboard, while here the keyboard is separated. Actually, IBM keyboard are still looked for in the in the market, because they are extremely robust. So essentially, you can see, you have, I think you have seen this, but it was a modular system. So inside it had the bus, much like the Altair, and you have, for instance, to buy a video card just to connect a monitor. It had not integrated video like the Apple II. And no sound. You have to buy a card for the sound. You have to buy a card for the printer. So essentially, it was like the Altair, almost an empty box, unless you buy the top level with floppy disk and with everything inside. So in the main board, there was very little. You can see that almost all connected to external devices like a floppy disk, a hard disk, printers, and so on, video card, are essentially cards that had to be fitted inside the bus. And this was one of the first problems, because there was I don't remember, I think 8 expansion slots, and they were quickly filled just if you want to have one hard disk, one floppy disk, the monitor, and the printer, and a few things. But clearly it was also expandable. While the Apple II, you had to stay with what was offered or little more. Also, in the Apple II, you could put, I don't remember how many, but a very few cards inside. For instance, there was a card that with another processor that allowed to run CPM on the Apple II. But in the IBM world, you could, after producer have started developing different options, you could afford to have a higher quality video card or a higher quality sound card, and so on. And clearly, the answer of the Apple was to develop the Apple III, which was a complete failure. And so for a certain number of years, the IBM PC was the top level of personal computers for business, essentially business purposes. And okay, so I think that for today can be enough, instead of entering the success and all the history of the PC, IBM PC world. I think, leave with the first step. The first step was Microsoft looking for an operating system for his new IBM PC. He thought to use CPM because it was the most sophisticated low-level operating system. However, when they visited the Kindle of Digital Research, he was outside the home. His wife did not want to sign the agreement with IBM in her husband's absence. And so since Gates was already in contact, Gates said, okay, I have a system compatible, very similar to CPM, and he signed the agreement. Actually, he had absolutely nothing about the DOS, but he knew that another researcher, not I think a private person, had been developing a quick and dirty DOS similar to CPM, more user-friendly and less clearly sophisticated. And so Gates hired Patterson with the agreement that he had to sell his system to Microsoft, to Bill Gates, and Bill Gates passed this software with his BASIC, which was actually developed by Bill Gates, to IBM. And that's how world essentially started to change in the middle of the 80s. I think that for today it is enough. Other 60 or almost 70 slides, and so we start again next week with the DOS world. Okay. Are there questions, comments, or anything more? Okay, if not, remember to mark your participation in the form, and see you next Thursday.
Okay, thank you.
Bye-bye.
Bye.